Hi everyone, Sahil Bora here from C++BetterExplained.com, and in today's video module we're going to be continuing talking about templates in C++. But in today's video we're going to be talking about template metaprogramming in C++. And now be advised that I strongly recommend that you guys watch my other video explaining the foundations of templates in C++, as template metaprogramming is going to be a continuation of talking about templates. So with template metaprogramming in C++, and in today's video, I think it's better today that I'm going to be going over some PowerPoint slides and some diagrams explaining how we can utilize template metaprogramming in C++. We all know that when we are writing a C++ program, we are coding a sequence of instructions which creates and modifies data. The simplest way to describe what template metaprogramming is that template metaprogramming is a sequence of instructions which modifies and creates programs. C++ templates that have been created can be customized at compile time with the help of metaprogramming. So as we've got in our block diagram here, we have our C++ source code in our IDE, and then what we also have is a template compiler. So this template compiler here that we have in red here, this is where the magic happens of where template metaprogramming can happen here, and then it goes on to our C++ compiler, say for example inside Visual Studio or Xcode, and then it turns that C++ code into machine code after it's run through the template compiler code, through the C++ compiler, and into machine code to an executable that can be run. You have to understand that when we are using templates, when you are running the code, it's going to generate different data types without being rewritten every single time a template that will be reused. So a great example is the stdvector. It's actually not a class. It's a template built in the standard template library, which applies C++ templates to generate the correct vector class for each type of data being used. So, say for example, if we're using the stdvector from the standard template library, the compiler can generate a code for the vector of doubles and vice versa if integers were used. So you need to have a diagram in your mind. So if we call a vector, if we use template metaprogramming, we can either choose whether it's either going to be choosing itself whether it's either going to be using doubles or integers for the stdvector. So you need to understand that meta functions are a basic unit of metaprogramming. So meta functions is simply a function of working types which the entities can be manipulated. Let's look at an example that we've got right in front of us right now of this simple meta function that I've got here of throwing balls. So in line number 10, you can see that the templates throws balls is the meta function which takes a type and throws away all the balls. The key concept to take away from this example is that template metaprogramming is used to generate code automatically. I know this is only a very brief example of template metaprogramming, as it can go really deeper into design patterns, code documentation, and many other advanced programming concepts. But I only wanted to touch with you guys today on what C++ template metaprogramming is, and a basic overview and a basic example of how it's being used.